Hello, everyone. Today, I would like to take this opportunity to welcome you and thank you for joining us to learn more about digital cockpit that shows us the future in-vehicle technology and user experience. In today's section, I will cover 4 topics. What is cockpit and market trends? Why this system evolution is happening? And how Infineon can help with cockpit design. And last but not least, the summary. So when we talk about automotive megatrends, we believe future cars become cleaner, safer, and smarter. These trends are also driving e-architect evolution towards software-defined vehicle, and also push the transformation from mechanical hardware-centric vehicle to a software device on wheels. All of these changes will have major impact on all vehicle ECU systems, such as powertrain, ADAS, and infotainment system. As a car gets smarter, the user experience becomes a major differentiator. This especially affects infotainment cockpit system architect design. People always want more intelligent and personalized system, such as higher resolution displays to stream media contents, and also sometimes the increased connectivity for better entertainment. And also, very important, when we reach higher level autonomous driving, the passenger and driver on the car will have more free time, which they can focus on more on other topics, such as entertainment and also work. All of this also will push cockpit to be more intelligent and capable to support this requirement. So now let's take a deeper look about growth driver for the cockpit. I think most of you may find out we want mobile capabilities across all aspects of our lives, including vehicles. Especially when 5G, cloud computing, and autonomous driving appearing in cars, the cockpit is treated as more social and connected space. And also many use cases that we found in our consumer electronics in the daily life will be duplicated in a car. That just follows consumer electronics trends quickly. And during the transition from traditional electronics vehicles to electronics vehicles, the human-machine interface and user experience become very important for OEMs. Especially for electronic vehicles, they want to increase their brand awareness. Because nowadays, we can find out more customers make their purchase decision based on the user experience in car. And also, very importantly, the car OEM are looking to generate additional revenues through software service. And they need these features can be added or updated through the project life. And all of this also require an intelligent cockpit system. So with that, the cockpit plays a very critical role to enable vehicle to be more digital, more software-oriented, and more connected. So when we look at content for infotainment system, it's clearly that is increasing. Back to 1990s, radio and CD are all about entertainment that we can find out from our car. And then we have touch display and also CarPlay enabled us to use many cell phone functions while when we're driving the car. And going forward, many more functions such as instrument cluster, heads-up display, passenger entertainment that also will be seamlessly integrated into the cockpit, and which can provide much better user experience to the passengers and drivers. So when e-architect moved towards to higher performance computers, we found out system integration will become mainstream, which also supported by powerful application processors and also centralized software platforms. The cockpit system will be scalable and also expandable. This also can be upgraded in the future. By that time, vehicles will become a data center on wheels, which allow us to enjoy new convenience all the time. So what we will see the major changes when transforming to the cockpit from the traditional infotainment system. In short, we see the growth in the following 5 main areas. For the system architect, with the system moving to the high-performance computer architect, the cockpit system will use high-performance SoC. Because of complexity, typically a microcontroller will be also required to facilitate with SoC to manage interface, car networks, and sometimes safety. In such system, a high NOR flash, high-performance NOR flash, and high-density NAND also will be required. Due to the complexity of the cockpit, this is centralized system architect. The software also plays a very important role, not only for managing the latest application software, but also for managing different operating systems, which can meet different functional system requirements. Just give you one example. The cluster requires SOB, and also it is real-time sensitive, but head unit is more focused on application, which does not require that. So in cockpit system, in this environment, a hypervisor is required to facilitate running multiple operating systems simultaneously. About human-machine interface, this is always a feature that customers are willing to pay for. One of the big changes you may already noticed, which you can find out more displays in the cars, and also the graphical quality are continues to improve. We talk about wireless network, and also at cockpit be invented as more and social connected space with rich contents and service. So that's come back to connectivity again. A robust connectivity with higher bandwidth and also security are required. This also can be update our software frequently because consumer use case can evolve at any time. Audio. The audio is another important part of things, how passengers perceive their environment when they are on car. And this is another big area for better user experience. Customers are always looking for enhanced audio system, not only for premium car, but also for lower-end car. But last but not least, there also have the huge growth potential at in-cabin sensing, because that make it possible for many new use cases for entertainment, such as gaming. Customers' requirements drive the growth, that's true, but the cost is a big factor that OEM need to consider. So we'll closely monitor that trend. On the other side, we also see the potential trend that level 1 or level 2 ADAS function could be also potentially part of a cockpit, because the SoC used for cockpit already have enough computing power to support it. If with that such design, this also could save the total system cost. So we'll see how that system will evolution will go happen. We will continue to see more accelerated innovations and new features to be added to the cockpit. All of this will drive huge demands for controllers, sensors, and also connectivity devices. So we talked about a lot of new features that are being added for cockpit, and also we can see that user experience will be significantly improved. So it will be no surprise that cockpit systems grow much faster compared to other systems within infotainment. According to Strategic Analytics, the cockpit is expected to grow at compound annual growth rate of 42% to reach to 40 million units in 2029, while head units and cluster system will decline after 2025. Although as of today, we still see the huge volume on head units and cluster, but clearly all the growth come from cockpit. So after we talk about cockpit market trend, now we will talk about why cockpit evolution changes are required from system architect perspective. So first, we will start with general automotive E-architect evolution. As we may know, driven by software-defined vehicle architect, the high computing vehicle system are required to move from distributed architect to a more centralized structure with more powerful but a few electronics control units. An additional benefit of this change is the significant reduction in wiring. In a domain architect, the ADAS, infotainment, and vehicle motion will still remain in their own domains, but this could rapidly transform into a central car compute architect, which the separate domain controller evolved to more powerful and complex central car computers. These computers will compromise body and comfort, partially vehicle motion, and partially ADAS functions, sharing wireless to a function network, allowing increased saving on both weight and cost. In the long term, will also evolve to the full car computer architect, which is software-defined car. This architect would enable a single or multiple central car computers with the most advanced zones, improve sharing of wiring, and full function network, and the lowest possible weight and the cost. So this diagram that reflects current classical infotainment system that has been evolved over the last several years. The partitioning can have several dedicated electronic control units. As you can see in the middle, the central of the human-machine interface, the instrument cluster and head units, it has separate displays and also controlled by different electronic control units. The TCU, also called telematics, provides a gate to the outside world through the satellite and cellular interface that also uses a separate ECU system. The heads-up display that nowadays we can say more, but previously this is kind of like a higher-end features only for premium car. For in-cabin monitor systems such as DMS or OMS, these are new applications which are driven by autonomous driving and mandated safety requirements. So all of these dedicated electronic control units are designed and manufactured from the separate Tier 1 suppliers. This diagram now describes the evolution to a software-centralized approach, which uses a single high-performance cockpit domain controller or computer. This is also what we say for the new trend. It aggregates formal cluster or head units with a single software and also hardware platform. And also depending on the performance of the SoC used in a system, the cockpit also can support more features such as heads-up display, surrounded parking, and driver monitor system. This complex and centralized software and hardware architecture will enable OEMs to add functions and also update their software easily based on a more standardized hardware and software platform, as well as operating system. So, as we talked, with transforming to this new centralized system architect, definitely there are also a lot of challenges for OEMs and Tier 1 they need to face. So when system moves to the software-oriented and centralized architect, this means decoupling of the functions from the ECU, and also the software for these functions also need to be integrated into the central computer. And no doubt, because there have a lot of software update requirement, we also see a huge focus from OEMs on security and software updates. This is not only for cockpit infotainment system, but also across all applications in vehicle. Additionally, the OEM need to have the standardized solutions which need to be replaceable hardware and can be easily migrated and updated so that they can bring the system, especially new design, to the market quickly. all of the requirements that just been talked have greatly increased the complexity of the hardware and software. This also increases the challenge for OEM to achieve the financial return on their investment in short term. This will require updated automotive ecosystem partnership. So let us take a look about cockpit ecosystem transformation. In the past, the automotive ecosystem is a vertical supplier structure with different tiers. For example, if you say from left side, the tier 3 provide raw material to tier 2s, and in return, tier 2s like Infineon provide tier 1 and with the modules and components. And then tier 1 provide OEM with a system or ECUs based on requirement. But however, this does not allow OEMs to strive for more centralized architecture because each tier 1 could have different software and also hardwares. But OEMs also want to follow the path of centralization, so they need to rely on suppliers to develop a more collaborative approach and standardized system with full integration with all components. This not only for infotainment, but also apply for other systems in the car. This centralized system platform will require OEM to engage and collaborate more closely and directly with all its suppliers, like we're showing that on the right side. All right, so after the introduction of the cockpit, so now it's time to see how Infineon can help you with the cockpit design. So first of all, for those who may not know Infineon, I would like to give you a brief introduction. So Infineon is one of the global top 10 semiconductor supplier with headquarters in Munich of Germany. We were founded in 1999, which was spun off from Siemens. As end of September 2021, our financial revenue for 2021 is about 11 billion euros, of which automotive business accounted for 44%, also equal to 4.9 billion euros. The rest of the business comes from the other 3 divisions: connected secure systems, power and sensor systems, and also industrial power control systems. So currently, Infineon, we employ more than 50,000 people worldwide and has 56 R&D and manufacturing sites in the world. With our leading technology, excellent quality and manufacturing facilities, Infineon has #1 positions in automotive semiconductors and for power supplies. Regarding automotive products, as said, we're #1 supplier in the world. We have industry broad portfolio. It can cover all major automotive applications. As you can see from the chart, our products are across sensors, microcontrollers, memories, power, and wireless connectivity categories. This perfectly matches the requirements needed for modern automotive systems, such as zone control, power distribution, battery management system, cockpit inverter, and autonomous driving. So specifically for a cockpit system, we also have broad product portfolio to help OEMs and Tier 1 to keep up with rapidly changing design requirement. From left side, for computing functions, we do not offer SoC or application processor, but we have a wide range of microcontrollers. For example, Travel 2 body microcontroller can be used as a vehicle interface processor, or Travel Cluster MCU, which has embedded graphic engine, and it is a good graphic controller that can be used as a backup safety graphic controller for cockpit. So Infineon is also a market leader providing different type of security solutions, which include optical family for embedded system to protect integrity of the information of the devices. We also have variety of the power products, such as MOSFET and gate drivers. this has been widely used in automotive system. And also, we, as mentioned before, we're the #1 market leader for power supplies. And also for cockpit system, so we know that a lot of memory being used for cockpit, and also we see the NOR flash is often required to store the critical code or to enable fast boot. So we have a complete NOR flash offering. On the right side, on the sensing part, Infineon also have provided a broad range of sensing products that dedicated for automotive use case, such as touch controller support from a capacitive button sliders over touchpads up to 35-inch touchscreens. We also have high-performance MEMS microphone for sound-related applications. We also have automotive image sensor based on 3D time-of-flight technology for in-cabin monitor system. On the connectivity, Infineon has industry-leading Wi-Fi and Bluetooth products, which support CarPlay, Android Auto, and MirrorLink, that for cockpit. So this is an example of the cockpit system block diagram. As you can see, it is a colorful chart, and all products with colors, that means Infineon has a solution for it. And for each function, different Infineon products can be selected according to the system design. With this broad product portfolio, we believe it will provide you convenience to design a scalable cockpit system. So let us take a little bit of time to take one more step to find more details of some of these products that are used for cockpit. As we mentioned in the previous slides, Infineon has a wide range of microcontrollers. So as you can see, this chart depends on performance. We offer 3 different types of microcontroller. The automotive PSOC, which is based on the ARM Cortex-M0 core, combining with programmable analog blocks and CapSense, which is perfect for touchscreen and CapSense-based buttons and sliders. Our multiple touchscreen controller also works with many situations, such as water droplets, also can be tracked with up to 5mm thick gloves or overlays, also support advanced features such as hover, fall sensing, and haptics. So Infineon automotive touchscreen controller has more than 50% market share as of today. Another product family, which is Traview T2G product family, this is another ARM core-based micro MCU product family. It has scalable lineup with single M4 core up to dual M7 cores. It also supports up to 1500 DMIPS, but it is also very power efficient, as low as 35 micron in typical deep sleep mode. So Traview, like T2G MCUs, also integrate hardware security modules to support higher security requirements, which is so important for over-the-air updates. So as of today, this product is widely being used as companion MCU to SoC in many OEMs' cockpit designs. The last product family, the RX products, this uses Infineon's tri-core architect. It contains a RISC processor core, a microcontroller, and DSP in one chip. It has high performance and also support advanced SOD safety features, which are ideal for domain control and sensor fusion applications. This product also being used and designed as reference design provided by several leading SoC suppliers. So here's several pictures, and I'm showing some system examples that enabled by Infineon Automotive PSOC and microcontrollers. As you can see the pictures, our products is widely used for different human-machine interface applications that within the cockpit, from the touchpad in the steering wheel to the touchscreen of the passenger displays. And when we talk about NOR flash, Our history on the NOR flash has more than 30 years ago with AMD. The NOR flash memory was also spun off from AMD in 2005. So before NAND is commonly used at infotainment, a NOR flash is always been required for code and application storage. Although the UFS or eMMC are commonly being used in a cockpit system now, but a NOR flash normally is still required to store the critical code. So for Infineon, we have exclusive mirror bit technology. This technology enables double the number of the bit per cell for high-density memories. So our flash products are architected and designed to deliver the highest level of safety, reliability, and security specifically for automotive systems. And very importantly, our NOR flash are also qualified in many SoC partners' reference designs. So that make our customer very easily to design our parts into their cockpit systems. So we also discussed about the wireless because now we're getting to the connected car. So that's why we're saying that Apple CarPlay and Android Auto have become standard features of in-car entertainment system, which also thanks to the robust Wi-Fi and Bluetooth technology. So Infineon has industrial-leading wireless technology and products. This cover different automotive applications. As you can see from the chart, from traditional infotainment to the cockpit, and including telematics, and even for a lot of new use cases such as car access and also EV charging, we do have solutions to support that. So when we specifically talk for cockpit infotainment system, we have different Wi-Fi Bluetooth combo and standard low-energy Bluetooth parts to support the market requirement. The latest Wi-Fi Bluetooth combo, A9570 and A9570XR, are Wi-Fi 6. We also call that as A02.11ax standard. So this standard compliant. It also provides simultaneous operations in both 2.4 gigahertz and 5 gigahertz bands, as well as multiple input, multiple output. So this bandwidth and software architecture enabled by our solutions allow customers to support different simultaneous application scenarios, especially for cockpit system, such as driver and passenger devices streaming, high bandwidth data, and also media contents, mirroring phone or tablet displays by using Apple CarPlay or Android Auto without relying on the cellular data service. As of today, so many OEMs are using our automotive wireless solution at infotainment and cockpit because of our demonstrated high performance, scalability, and also software support. So we also talk about increased sensor use case at advanced cockpit system. Because at premium cockpit system, we notice that advanced human-machine interface features become a differentiation for OEMs. Just for one example, and one of Chinese leading EV manufacturers, they launched a SUV in June of 2022. It equipped 5 high-definition displays for driver and passengers, a large heads-up displays, a face and gesture recognition system with 3D-based time-of-flight sensors, and also an audio system with microphone in every passenger seat. All of these features greatly improve the user experience that in a car. So Infineon, as we said before, we're industry leader in sensor products for automotive and consumer. We're #1 MEMS microphone supplier. And also with our automotive-grade products that also meet automotive stringent requirements. Previously, the OEMs used consumer-grade microphone for lower system cost, but we also see the trend moving towards to automotive-grade because of a quality requirement required by premium audio system. On the 3D-based time-of-flight sensor and also 60 gigahertz radar sensor, this has been commonly used in consumer market. But nowadays, we see more automotive customer that also adopt that solution. We already see some automotive customer already use Infineon automotive grade products in that sensing application for cabin. So the augmented reality heads-up display that is replacing the traditional HUD heads-up display. We see that as a clear trend because it provides much better navigation experience with virtual information. Infineon, we also have the maps-based laser beam scanner that for like AR heads-up display solution, it provides large horizontal and vertical field of view at competitive system cost, especially compared to existing AR HUD solutions. All right, we talked about a lot regarding that cockpit markets, system evolution, and also Infineon solutions. To sum up what we have discussed today, I would like to give a summary here. So overall, the market for traditional headiness and cluster is still huge, but clearly we see the growth is shifting to the cockpit because of fast increased human-machine interface and user experience requirements. This is also followed quickly with consumer electronics trends. Especially with the new software-defined vehicle architecture, this also drives this transition from the traditional distributed ECU system go to the centralized system. So for Infineon, we have long history in automotive and automotive infotainment system. With our broad product portfolio, we believe we are able to help our customer to design a differentiated cockpit system. All right, so this is my last page. And because of time constraint, we could not talk more details about cockpit and also our products. But please go to our website to find out more information, and you will see more information regarding application and products. And then we're going to have the Q&A sections, and myself and my colleagues, Thomas Libercho, we will answer your questions. Thank you very much.